Hi students, I am Fani Kumar, Reasoning and Stats faculty. In the view of CA Foundation exams, I will briefly revise all the statistics formulas. This video will be very useful to revise all formulas within a short period of time. Okay, now we will go to the video. Firstly, statistical description of data. The formulas involved in this chapter are: firstly, find number of classes. For finding number of classes, it is denoted by K. Formula is range by width of the class. Or you can find number of classes by using K formula 1 plus 3.322 log n, which is also known as Sturge's formula. Whenever width of the class is known, use this formula K equal to range by width of the class. Otherwise, Sturge's formula we can use to find number of classes. Here, what is meant by range? Larger value minus smaller value of the given data. Similarly, width of the class can be found by using the difference between upper class boundary and lower class boundary. So, width of the class is UCB minus LCB. Width of the class is also known as size, interval, length, magnitude, so on. So, always width means UCB minus LCB, difference between class boundaries, not the limits. Similarly, we know that we have to convert inclusive to exclusive. That means we have to convert limits to boundaries. On converting limits to boundaries, the formulas: LCB, lower class boundary, is nothing but LCL minus D by 2, and UCB, upper class boundary, is UCL plus D by 2. Similarly, for finding the mid value or class mark of the class, the formula is upper class limit plus lower class limit by 2, or UCB plus LCB by 2. That means boundaries, upper class boundary plus LCB by 2 also you can use. Similarly, next formula is frequency density. Frequency by width of the class. To find the frequency density of any class, frequency by width of the class is the formula. Remember here, width of the class. While finding width of the class, please use only boundaries. Don't use limits. Okay, always the difference between boundaries is only width of the class. So frequency density is frequency by width of the class. Relative frequency means frequency by total frequency. Percentage frequency means frequency by total frequency into 100. That means relative frequency into 100 is percentage frequency. And similarly, coming to pi diagram, sometimes you are going to find central angle of the components. For finding central angle, the formula is component value divided by total of all components into 360. And when mid values are given instead of class intervals, from mid values you can find class boundaries also. Formula is for finding LCB mid value minus D by 2, and for finding UCB mid value plus D by 2, where D is the difference between the mid values. These are the formulas involved in the first chapter, that is statistical description of data. Now we will move on to the next chapter, formulas, measures of central tendency. Measures of central tendency. In this, already we know the data can be classified into individual series, discrete series, continuous series. I will discuss the formulas in the form of a table now. Individual series, discrete series, and continuous series. So firstly, in central tendencies, our first measure of central tendency is arithmetic mean, AM. Arithmetic mean, it is denoted by X bar, and individual series formula is sum of the values by number of values. Sum of the values by number of values, summation X by N. Similarly, coming to discrete series, the formula will be summation Fx by summation F, or summation Fx by capital N. X bar formula in the discrete series is summation Fx by capital N. Use the same formula for continuous series also. So X bar formula in the case of continuous series is summation Fx by capital N. Coming to arithmetic mean, there is another method which is also known as assumed mean method, and the formula for assumed mean method is X bar equal to A plus summation D by N, where A is assumed mean, sum of the deviations is summation D, and N is the number of values. This is about arithmetic mean. Okay. Next, coming to median. Median is denoted by m, and formula for median in the case of individual series is n plus 1 by 2th term, where we have to write in ascending order, and after that find n plus 1 by 2th term. Median is n plus 1 by 2th term. Remember here, sometimes he will ask rank of median. If he is asking rank of median, our formula is just n plus 1 by 2. If it is median, n plus 1 by 2th term, and if it is only rank, just n plus 1 by 2. Similarly, coming to discrete series, median formula is capital N plus 1 by 2th term. And coming to continuous series, median formula is L plus n by 2 minus Cf by f into C. This is median formulas in the case of individual, discrete and continuous. Sometimes median in the case of individual series, for odd number of observations we are using the formula n plus 1 by 2th term. For even number of observations also you can use the same formula, or otherwise median formula in the case of even observations is n by 2th term plus n plus 1 by 2th term, n by 2th term plus n by 2 plus 1th term divided by 2. This is in the case of even number of values, median formula n by 2th term plus n by 2 plus 1th term divided by 2. Okay, this is about median. Later we will discuss about quartiles, deciles also. And next coming to mode. Mode formula in the case of individual series. In individual series there is no formula for mode, just repeated value. The value which is repeated more number of times is the mode for individual series. And for discrete series also there is no formula for mode. The value having maximum frequency is known as mode. Okay, value having maximum frequency. Coming to continuous series, we have the formula for mode, which is mode is denoted by Z. Okay, Z equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into C. Formula for mode in the case of continuous series, L plus F1 minus F0 by 2F1 minus F0 minus F2 into C, or otherwise you can use this formula also, L plus D1 by D1 plus D2 into C, where D1 is the difference between F1 minus F0, maximum frequency and preceding frequency of the model class, D2, F1 minus F2, maximum frequency and succeeding class frequency. Okay, this is how you can compute mode in the case of continuous series. Next, coming to geometric mean. Geometric mean formula in the case of individual series is GM is nothing but nth root of the product of the values, nth root of x1, x2, so on xn, or you can apply formula like GM equal to anti-log of summation log x by n. In individual series, these are the formulas for GM. And coming to discrete series, GM formula is anti-log of summation f log x divided by Kaplan. Anti-log of summation f log x by Kaplan, where x is the mid value and find logarithm, and after that GM. Similarly, for continuous series also you can use the same formula, anti-log of summation f log x by Kaplan, geometric mean. And next coming to harmonic mean. HM formula in the case of individual series is HM is the reciprocal of AM and also reciprocal of the values. That means n by sum of the reciprocals. So harmonic mean is the ratio of number of values and sum of the reciprocals. So HM formula in the case of individual series, n by summation 1 by x. In the case of discrete series, it can be written as capital N by summation f by x. And continuous series also use the same formula, capital N by summation f by x. This is how you can compute individual and discrete continuous AM, GM, HM, median and mode. After this, we will discuss about combined arithmetic mean, combined GM, combined harmonic mean. Combined AM. Combined arithmetic mean formula is, it is denoted by x12 bar. Formula is n1 x1 bar plus n2 x2 bar by n1 plus n2 for two groups. If it is three groups, n1 x1 bar plus n2 x2 bar plus n3 x3 bar by n1 plus n2 plus n3. Combined AM. Similarly, we have combined GM also, where only formula is important, problem is not important. For combined mean, both theory and problem is important. Combined GM formula, it is denoted by GM12 and the formula is anti-log of n1 log g1 plus n2 log g2 divided by n1 plus n2. This is combined GM formula. Similarly, we have combined HM also. Combined HM formula is HM12 equal to n1 plus n2 divided by n1 by h1 plus n2 by h2. This is combined HM formula. Combined HM. HM12 equal to n1 plus n2 by n1 by h1 plus n2 by h2. Okay. After this, we will go to weighted AM, weighted GM and weighted HM. Okay. First of all, weighted AM. Weighted AM formula is, weighted AM is denoted by XW bar, where W is weight. Instead of frequencies, we will have weights, and the formula is summation WX by summation W. Weighted AM formula. Similarly, we have weighted GM also. GMW, that is weighted GM is anti-log of summation W into log X divided by summation W. Instead of frequencies, weights. Combined HM, which is also used in average speed. So combined HM formula, summation W by summation W by X. This is the formula for combined HM, which is also used in average speed. Okay. Similarly, for any two values, we have a relation between AM, GM and HM, which is nothing but GM whole square equal to AM into HM. For any two values, the relation between AM, GM and HM is this one. And similarly, we have another relation, the relation between mean, median and mode, which is nothing but mode equal to 3 median minus 2 mean. 3 median minus 2 mean. This relation can also be expressed in empirical relation like this. Mean minus mode equal to 3 times of the difference between mean minus median. Okay. This is the relation between mean, median and mode, and relation between AM, GM and HM. After that, we will now discuss about other positional averages, quartiles, deciles, octiles, percentages like that. Coming to quartiles, quartiles divide the data into 4 equal parts. Again, coming to individual series, Q1 formula, first quartile formula is n plus 1 by 4th term. First of all, ascending order and then find n plus 1 by 4th term. First quartile is n plus 1 by 4th term. If it is rank of Q1 means just write n plus 1 by 4. Remove term. N plus 1 by 4th term is Q1 and Q1 rank is only n plus 1 by 4. Coming to Q3, third quartile formula is 3 into n plus 1 by 4th term. And if it is rank of Q3 is 3 into n plus 1 by 4. Similarly, deciles. I am writing a general formula. Kth decile, dk, k into n plus 1 by 10th term, where k can range from 1 to so on 9. First decile means n plus 1 by 10th term, second decile 2 into n plus 1 by 10th term, so on. Ninth decile means 9 into n plus 1 by 10th term. And if it is rank, kth decile rank can be denoted by just k into n plus 1 by 10. Suppose he was asking the rank of 6th decile, 6 into n plus 1 by 10 is the formula. Like this, decile and rank. Similarly, percentile. If it is kth percentile, formula in the case of individual series is k into n plus 1 by 100th term. And the rank of kth percentile is just k into n plus 1 by 100. That means again if he is asking 60th percentile, rank of 60th percentile is 60 into n plus 1 by 100, and if it is the value P60 is 60 into n plus 1 by 100th term, where k can range from 1 to so on 99 percentiles. So octile, quartiles, deciles, percentiles. Similarly, we have octiles also, which is not much important. Kth octile can be denoted by k into n plus 1 by 8th term. Octile means by 8, and if it is rank again n plus 1, k into n plus 1 by 8, rank of kth octile. If it is kth octile, k into n plus 1 by 8. Suppose if it is third octile, 3 into n plus 1 by 8 is the rank, 3 into n plus 1 by 8th term is the third octile. Like this, in individual series you can find quartiles, octiles, deciles, percentiles. This is about individual series. Coming to discrete series, what will be the Q1 formula? First quartile, capital N plus 1 by 4th term, and if it is rank, capital N plus 1 by 4 is the rank. And third quartile means Q3 in the case of discrete series, 3 into capital N plus 1 by 4th term, and if it is rank again, just 3 into capital N plus 1 by 4. Kth decile, it is k into n plus capital N plus 1 by 10th term, and if it is rank, k into capital N plus 1 by 10, where k is 1 to so on 9. If it is kth percentile, discrete series, k into n plus 1 by 100th term is the formula, and if it is rank, k into n plus 1 by 100 is the rank. Kth octile, k into capital N plus 1 by 8th term, and if it is rank of kth octile, k into capital N plus 1 by 8. Like that, in discrete series, you can compute other positional averages. Coming to continuous series, which is important one. For continuous series, Q1 formula, just like median. Median is L plus n by 2 minus CF by F into C. For continuous series, first quartile formula is L plus n by 4 minus CF by F into C. First quartile. If it is third quartile, Q3, L plus 3n by 4 minus CF by F into C. For continuous series, always it must be in exclusive series, okay? Similar. Coming to deciles, again on a kth decile formula, you can write it as L plus kn by 10 minus CF by F into C, where k ranges from 1 to so on 9. If it is fifth decile, D5, L plus 5n by 10 minus CF by F into C is the formula. Similarly, kth percentile means Pk, L plus kn by 100 minus CF by F into C. Okay, if it is 20th percentile, P20, L plus 20n by 100 minus CF by F into C, where k ranges from 1 to so on 99, up to 99 percentiles you can calculate. Similarly, octile, if it is kth octile, L plus kn by 8, octile means 8 parts by 8 minus CF by F into C. Okay, these are the formulas in first chapter, that is basic chapter and very important chapter, measures of central tendency. These are the formulas. Okay, after that, now we will move on to next chapter, measures of dispersion. We will discuss the formulas involved in the measures of dispersion. Firstly, range. Formula for range is L minus S, or maximum value minus minimum value, larger value minus smaller value. Coefficient of range. Coefficient of range formula is L minus S by L plus S into 100. If it is expressed in percentages into 100, otherwise L minus S by L plus S. Okay, this is about range, first measure of dispersion. And second measure of dispersion is quartile deviation, or it is also known as semi-interquartile range. Quartile deviation or semi-interquartile range. Formula is Q3 minus Q1 by 2. Interquartile range is Q3 minus Q1, and semi-interquartile range means by 2. Quartile deviation, Q3 minus Q1 by 2. This is absolute measure. Coefficient of QD is Q3 minus Q1 by Q3 plus Q1 into 100. This is the formula for coefficient of QD. If it is symmetric distribution, coefficient of QD formula will be quartile deviation by median into 100. Coefficient of QD for symmetric distribution, QD by median into 100. Next, coming to mean deviation, MD. Formula is sum of absolute deviations from any average divided by n, where here A means either mean or median or mode. A may be x bar, or A may be m median, or A may be z. Mean deviation about mean means x bar, mean deviation about median is median, mean deviation about mode means A is z. Okay, so MD formula, sum of absolute deviations by n in the case of this individual series. If it is discrete or continuous series, frequencies, MD formula is summation f into mod x minus a by capital N. This is the formula for MD in the case of discrete and continuous. Again, coming to coefficient of MD. Coefficient of MD is relative measure whose formula is MD by A into 100. Here again, A means if it is computed with respect to mean, A is mean, with respect to median means A is median, with respect to mode means A is mode. Okay, coefficient of MD, MD by A into 100. And coming to the next measure, standard deviation, SD. Formula is square root of individual series formula, square root of summation x minus x bar whole square by small n. If it is frequencies, square root of summation f into x minus x bar whole square by capital N. And if you remember the formula of mean, automatically you can remember mean deviation, standard deviation like that. Coming to mean, individual series summation x by n, instead of x, substitute absolute deviation mod x minus a, you will get MD formula. Similarly, coming to SD, instead of x, substitute summation x minus x bar whole square. Mean formula in the case of frequencies, summation fx by n, instead of x, take x minus x bar whole square and obtain the root, SD formula. If it is variance, remove the root, sigma square. So what will be the formula for variance? Sigma square summation x minus x bar whole square by a capital N, or if it is frequencies, that is discrete or continuous, summation f into x minus x bar whole square by capital N. This is variance. You can use other formula also for standard deviation, which this is direct formula. Indirect formula for SD is like this: square root of summation x square by n minus x bar whole square. This is individual series again. If it is discrete or continuous, formula for SD is summation fx square by n minus x bar whole square. If you remove the root, again variance formula will be computed. So this is about SD, and in SD we have two relative measures. One is coefficient of SD, which is known as SD by mean. Okay, sigma by x bar, SD by mean, coefficient of SD. And very important relative measure, coefficient of variation. Coefficient of variation, CV. CV formula is SD by mean into 100. That is CV, sigma by x bar into 100. This is the formula for CV, relative measure, most important relative measure. So after this, we have another formula, combined SD. Combined SD. Combined AM, combined GM, combined HM, and now combined SD. Combined SD formula is sigma 1 2 equal to square root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. This is the formula for combined SD, where sigma 1 square, sigma 2 square are variance, d1 square and d2 square are deviations from mean and combined mean. You have to compute combined mean, after that combined SD. Here you have some cases also. Suppose if n1 equal to n2, remove n1 and n2 in this formula. Then combined SD formula is nothing but square root of sigma 1 square plus d1 square plus sigma 2 square plus d2 square divided by n1 plus n2, divided by 2. n1 and n2 are equal means you have to delete n1 and n2. This is the formula. If means are equal, only means are equal but number of observations are not equal, then remove d1 and d2 in the formula. Why? Because deviations will become 0. When means are equal, combined mean also will be equal to this value. x1 bar minus x12 bar is 0, x2 bar minus x12 bar 0. d1 and d2 0 means combined SD formula is remove d1 and d2. So square root of n1 sigma 1 square plus n2 sigma 2 square divided by n1 plus n2. And if both number of observations and means both are equal, then what will be your formula, he may ask. If both are equal, remove n1 and n2 and d1 and d2 in the combined SD formula. Then combined SD formula will be, in this case, square root of sigma 1 square plus sigma 2 square by 2. Combined SD. Okay, these are different cases. After combined SD, now we will move on to the relation between QD, MD and SD. Relation between QD and MD, SD. In the case of symmetric distribution, we have a relation 6QD equal to 5MD equal to 4SD. So the relation between QD, MD and SD is this one. From this relation, it is clear that always SD will be larger than MD and the least will be QD. That means QD is always less than MD and MD is always less than SD. Anyway, if it is symmetric, 6QD equal to 5MD equal to 4SD, and if SD is known, QD can be computed by using the formula 2 by 3 SD, and if SD is known, MD can be calculated by using the formula 4 by 5 SD, 2 by 3, 4 by 5. Okay, these are the main formulas involved in this chapter, measures of dispersion. Okay, next, okay, after discussing central tendency and dispersion formulas, there are some more formulas covering central tendency and also dispersion. So first of all, arithmetic mean of first n natural numbers. Formula is n plus 1 by 2. If there are 10 natural numbers, 10 plus 1 by 2 is the mean. Okay, arithmetic mean of first n natural numbers n plus 1 by 2. And if it is SD, for first n natural numbers, SD formula is root n square minus 1 by 12. And variance means square of SD. That means variance of first n natural numbers n square minus 1 by 12. Okay. Similarly, if the given series is in AP, mean formula, arithmetic mean is first term plus last term by 2, A plus L by 2. If the given series is in AP, you can compute mean by using A plus L by 2. If the given series is in AP, SD formula directly is root n square minus 1 by 12 into D. That means variance is n square minus 1 by 12 into D square, square of SD. Okay. So, similarly, mean of first n even numbers, formula is n, and if it is SD for first n even numbers, formula root n square minus 1 by 3. Mean of first n odd numbers, formula n plus 1. If it is SD for first n odd natural numbers, root n square minus 1 by 3 is the formula for SD. And arithmetic mean of squares of first n numbers is n plus 1 into 2n plus 1 by 6. n plus 1 into 2n plus 1 by 6. And arithmetic mean of cubes of first n numbers is n into n plus 1 whole square by 4. These are the formulas which you have to remember. So coefficient of concurrent deviations. Coefficient of concurrent deviations. Formula is R equal to plus or minus square root of plus or minus 2c minus n by n. Here where n is number of deviations which is always less than 1 number of pairs. If number of pairs are 10, here number of deviations will be 9. If number of pairs are 11, you have to consider number of deviations as 10, like that. Please remember that point. In concurrent deviations, n is not number of pairs. N is always number of deviations which is 1 less than number of pairs. So this is the formula for concurrent deviations. Similarly, coefficient of rank correlation. Rank correlation coefficient. Formula is R equal to 1 minus 6 summation d square by n into n square minus 1. In the case of without repeated values, that means no ties, this is the formula. When there is ties, rank correlation formula will be like this: 1 minus 6 into summation d square plus summation m into m square minus 1 by 12 divided by n into n square minus 1. In the case of tied ranks, this is the formula where m means frequency of repeated value. For every repeated value, you have to calculate this one. and then add to summation d square, then rank correlation coefficient formula is this one. Concurrent deviations and rank correlation. Okay. And next important one is Karl-Pearson correlation coefficient. Okay. Karl-Pearson correlation coefficient formula is R equal to covariance of xy by sigma x into sigma y. If it is covariance is given and standard deviations are given, use this formula. If covariance is not given, instead of standard deviation, variances are given, this formula will be covariance of xy by root of variance of x into root of variance of y. Why? Because for variance, if it is root, it will give standard deviation. So, if these values are given, use this formula. Otherwise, if deviations are given, our formula will be summation x minus x bar into y minus y bar divided by square root of summation x minus x bar whole square, sum of squares of the deviations from mean of x, and into square root of summation y minus y bar whole square. This is deviations method. And another formula, no deviations method. Whenever values are given without these values, covariance, standard deviations, without deviations, you will use mostly this formula. The formula is n into summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x whole square and square root of n into summation y square minus summation y whole square. This is known as no deviations method formula for correlation coefficient, no deviations method. This is the Karl-Pearson correlation coefficient formulas. Okay. These are the basic formulas involved in correlation. Okay. So remember that correlation coefficient is independent of change of origin and scale, but it is dependent on only change of sign of the scale. Okay. So this is about correlation. Formulas are these one. Next we will move on to regression. Coming to regression, regression line of y on x or regression equation of y on x. Regression line of y on x formula. It is directly denoted as y equal to a plus bx, where a is intercept and b is slope. Or the regression equation of y on x can be given by the formula y minus y bar equal to byx into x minus x bar, where x bar and y bar are the means, and byx formula, again byx can be computed by using the formula r sigma y by sigma x, where r is correlation coefficient, sigma y and sigma x are standard deviations. If it is values are given, use this formula. If covariance is given, this formula will be converted like this: covariance of xy by sigma x square, variance of x. Okay. And covariance and variance are given means use this formula for byx. If none is given and only values are given, again you go to no deviations method, where formula is for covariance of xy, it is n into summation xy minus summation x into summation y divided by variance of x means n into summation x square minus summation x whole square. This is byx. X bar and y bar are the means. After calculating byx, substitute in the equation, then you will get the form y equal to a plus bx. Regression equation of y on x. If it is regression equation of x on y, regression equation of x on y means the form will be x equal to a plus by, where it can also be written like this: x minus x bar equal to bxy into y minus y bar. Again, coming to bxy, now our formula will be converted like this: bxy is nothing but r sigma x by sigma y, whenever r and standard deviations are known. If covariance is given, covariance of xy by sigma y square is the formula for bxy. Y is the denominator, bxy. In byx, x is the denominator. Similarly, if values are given, bxy formula in the case of no deviations method, numerator is the same. Covariance of xy means n into summation xy minus summation x into summation y, and by denominator n into summation y square minus summation y whole square, regression equation of x on y. Here, byx and bxy are known as regression coefficients. When regression coefficients are known, you can compute correlation coefficient by using the formula r equal to square root of byx into bxy. That means geometric mean of regression coefficients is nothing but r. Similarly, regression coefficients are independent of change but dependent on scale. Coming to that one, if u equal to a plus bx is the equation where x is changed to u variable by adding a origin and by multiplying b the scale. If it is the equation, and similarly y variable is also changed to v variable like c plus dy by changing origin and scale, and bxy and byx values are known. If you want to find the regression coefficient of BUV, regression coefficient of U on V, the formula is B by D into BXY. Regression coefficient of U on V, BUV, B by D, BXY. If it is regression coefficient of V on U, if you have to find, formula is D by B into B by X. Okay, these are the formulas in regression chapter. After this chapter, very important chapter, index numbers. So next, index numbers. You know, index numbers involves many formulas. Firstly, basic formula, price index for a single commodity. It is also known as price relative. P1 by P0 into 100, where it is denoted by P01. That means price index of 1 on 0, P1 by P0 into 100. If it is P10, formula is P0 by P1 into 100. Similarly, quantity index for a single commodity, which is also known as quantity relative, Q01, Q1 by Q0 into 100. If it is Q10, Q0 by Q1 into 100. Next, coming to unweighted index numbers, where no weights are taken for calculating the index numbers. In that, simple aggregate. Simple aggregate means no weights. Formula P01, price index of 1 on 0, summation P1 by summation P0 into 100. If it is price index, use this formula. Sometimes he may ask quantity index using simple aggregate. Then the formula is summation Q1 by summation Q0 into 100. If it is price, prices. If it is quantities, quantities. Similarly, in unweighted index number, simple average of relatives is the next method, where relative means, already we have discussed, relative means computing index for single commodity separately. That is also denoted by I. Relative means it is denoted by P if it is price, Q if it is quantity, or simply I. Here I means P1 by P0 into 100 for price, for it is quantity, I equal to Q1 by Q0 into 100. Now, after calculating I, using arithmetic mean P01, simple AM formula is summation I by N. If it is quantity index, simple AM of quantity index is summation I by N, where I is Q1 by Q0 into 100. Using GM also you can compute index numbers. If it is price index number, P01 anti-log of summation log I by N, where I is P1 by P0 into 100. If it is quantity index, Q01 equal to anti-log of summation log I by N, where I is Q1 by Q0 into 100. This is about unweighted index numbers. Coming to weighted index numbers, that means you are considering weights. Weighted aggregate formula, price index is summation P1W by summation P0W into 100. For computing price index numbers, weights are taken as quantities. Quantities are taken as weights. For computing quantity index number, prices are taken as weights. For price index, weights are quantities. For quantity index, weights are prices. So this is weighted aggregate formula. W means weight. By changing these weights, you can compute different formulas. We can get different formulas. First one, last prey index, where last prey is considering base year quantity as weight none. That means already I have told, for price index number, quantity or the weights. Here base year quantity, W means Q0. So last year price index number, summation P1 Q0 by summation P0 Q0 into 100. If it is quantity, our weights will be prices. So base year prices will be the weights. That means W equal to P0 in that quantity index. So last year quantity, summation Q1 P0 by summation Q0 P0 into 100. And sometimes he may ask price index number. Mostly he will ask price index. Sometimes he may ask quantity. No need to worry. In price index number formula, in the place of P substitute Q. If it is quantity, P will become Q and Q will become P. Then you will get all the formulas. Okay na? Price index number formula vaste quantity index number formula vachesthundi. In the place of P, substitute quantity, price will become quantity, quantity will become price. Next, passage index number. W is Q1. Current year quantity is taken as weights. So price index number passage means summation P1 Q1 by summation P0 Q1 into 100. If it is quantity, summation Q1 P1 by summation Q0 P1 into 100. Price index, quantity index. So please be careful about calculating if it is price or quantity. Please be aware and use the corresponding formula. Now coming to Bowley's formula, Nana. Bowley is nothing but AM of last pair and passage index. So Bowley formula is last pair summation P1 Q0 by summation P0 Q0 plus passage summation P1 Q1 by summation P0 Q1 divided by 2 into 100. Okay. L plus P by 2 simply. If last pair and passage value is known, L plus P by 2 is the formula for Bowley. And I am writing here only price index formula. If it is quantity, that means Bowley's quantity index number if he is asking like that. So change P into Q and Q into P. That means suppose Bowley's quantity index number formula means summation Q1 P0 by summation Q0 P0 plus summation Q1 P1 by summation Q0 P1 by 2 into 100. Similarly, Fisher's index, geometric mean of last pair and passage. So square root of summation P1 Q0 by summation P0 Q0 last pair into passage summation P1 Q1 by summation P0 Q1 into 100. Again I am writing price index. If it is quantity, change P into Q and Q into P. Simply, Fisher index number can also be denoted by root LP whenever last pair and passage values are known. Next, Marshall-Edgeworth formula. Marshall-Edgeworth formula. So, coming to Marshall-Edgeworth, weights are nothing but Q0 plus Q1 by 2. That means base year and current year quantity arithmetic mean is taken as weights. So, P01 summation P1 Q0 plus summation P1 Q1 by summation P0 Q0 plus summation P0 Q1 into 100. Marshall-Edgeworth price index. Walsh, geometric mean of base year and current year quantities are taken as weights. Walsh index number is also known as cross-weighted formula. Formula is summation P1 root Q0 Q1 by summation P0 root Q0 Q1 into 100. Okay, Walsh price index number. If it is quantity index number, summation Q1 root P0 P1 and summation Q0 root P0 P1 into 100 will be the formula. Kelly's fixed weight index number. Fixed weight means he was considering a fixed weight. That means W equal to Q. So Kelly's price index number formula is summation P1 Q by summation P0 Q into 100, where Q means fixed quantity. Okay. Similarly, quantity index means Q01 summation Q1 P by summation Q0 P into 100. Here weight will be fixed price. Price index numbers means weights are quantities. For quantity index numbers, weights are prices. So these are weighted index numbers, weighted aggregate method formulas. In weighted index numbers, we have another formula, weighted average of relatives. Weighted average of relative means again you have to consider relatives and weighted averages. So, weighted average of relatives, in that one, first formula is weighted AM. Weighted AM is also known as general index. General index where the formula is P01 equal to summation IW by summation W, where I is relative P1 by P0 into 100. So relative into corresponding weights, summation IW by summation W. Weighted AM formula is nothing but general index, summation IX by summation WX by summation W, weighted AM. Here instead of X there will be I, summation IW by summation W. Weighted AM. Similarly, we have weighted GM also, where anti-logarithms and logarithms will come. So P01 formula is anti-log of summation log I into W by summation W. This is weighted GM formula. So these are different formulas for computing index numbers, Nana. Again, in this chapter we have cost of living index number. Okay. where cost of living index number, for computing cost of living index number, we have two types of formulas. One is aggregate expenditure method. Aggregate expenditure method, where the formula is nothing but last year's formula. For computing CLI in aggregate expenditure method, formula is summation P1 Q0 by summation P0 Q0 into 100. Last year index is nothing but aggregate expenditure CLI. And family budget method, which is mostly used method, family budget method formula for CLI is general index, which is this formula. Okay, summation IW by summation W. Family budget method formula is this one. Okay, next in index numbers, fixed base index number, chain base index numbers are there. For chain base index, first of all we have to compute link relative. Formula for link relative is current value by previous value into 100. Link relative formula, current value by previous value into 100. After computing link relative, you can compute chain relative, CR or CBI, chain base index, where the formula is CR of that year, LR of that year into CR of previous year divided by 100. This is the formula for chain base index. LR of that year into CR of previous year by 100. Chain base index formula. Again, you have deflation. In deflation, purchasing power of money. Purchasing power of money formula is 1 by price index or 100 by CLI. Purchasing power of money 100 by CLI. Okay. Purchasing power is 100 by CLI, and real wage formula is money wage by CLI into 100. Money wage by CLI into 100. These are the formulas in index numbers, mainly unweighted index numbers, unweighted index numbers, cost of living index numbers. Okay, this is about index numbers. Next, we will move on to probability. In probability, main formulas are firstly complementary event probability. That means if A bar is complementary event, P of A bar is nothing but 1 minus P of A. Okay. And next, classical definition of probability. Classical definition of probability means if A is any event, probability of that event can be computed by using the formula number of favorable events, number of favorable cases divided by number of exhaustive cases. Number of favorable cases by number of exhaustive cases. That means favorable cases means suppose it can be denoted by M, and total cases it can be denoted by N. So probability of A can be computed by using M by N, favorable cases by exhaustive cases. This is the classical definition of probability. And after that, addition theorem of probability, which is P of A union B equal to P of A plus P of B minus P of A intersection B. Coming to this formula, if A and B are mutually exclusive, A intersection B will become 0. In that case, if A and B are mutually exclusive, then P of A union B will become simply P of A plus P of B. Whenever A and B are mutually exclusive, P of A intersection B is 0. So this is addition theorem probability. If it is 3 cases, 3 events, P of A union B union C, then our formula will be P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. For 3 events, addition theorem probability is this one. So, addition theorem. After that, conditional probability. P of A given B. That means probability of A given B. After B, we are computing probability of A. Formula is probability of A intersection B by probability of B. Here the condition is our probability of B must not be equal to 0. It must not be an impossible event. Okay, if it is an impossible event, we can't compute conditional probability. Similarly, P of B given A, P of A intersection B by P of A. Okay, these are the conditional probability formulas. In this conditional probability, again, multiplication theorem of probability is formula P of A intersection B equal to P of A into P of B given A. After A, we are computing B, dependent events. So P of A intersection B is this one. If it is independent events, A and B, P of A intersection B is equal to P of A into P of B. So union means plus, or union plus, all are like same. Into means intersection and AND. Intersection and product. That means intersection, union plus and or means addition theorem. Okay. So in this formula, in conditional probability formula, sometimes he will ask like this. If A and B are independent, what is the condition? P of A intersection B equal to P of A into P of B. If A and B are independent, then what will be P of A given B? What will be the formula? If A and B are independent, P of A given B is P of A intersection B by P of B, where P of A intersection B is P of A into P of B. P of B cancel. That means P of A independent means A is not depending on B. So individual probability will come. Similarly, if A and B are independent, P of B given A is equal to P of B. And similarly, if A is subset of B, what will be P of A given B formula? And if A is subset of B, clearly A intersection B is nothing but A. Okay, if A is subset of B, P of A intersection B will become P of A. So P of A given B, that means P of A by P of B. And if A is subset of B, what will be the formula for P of B given A? P of A by P of A, that means 1. If B is subset of A, P of A given B will become 1 and P of B given A will become P of B. Okay, these are the formulas in probability. Okay. Next, theoretical distributions. Binomial distribution. The PMF of binomial distribution, NCX, P power X, Q power N minus X. Where X can take the values from 0 to N and we will have N plus 1 probabilities. So mean of binomial distribution, NP, variance is NPQ, where always mean is greater than variance. If he is asking SD, root NPQ is the formula. And mode of binomial distribution formula is N plus 1 into P. It means it may be either unimode or bimode according to the value. Coming to Poisson distribution, PMF is e power minus lambda, lambda power x by x factorial, where x can range from 0 to infinite. And here lambda is the parameter, mean is lambda, variance is lambda. For Poisson, mean and variance is equal. For which distribution mean and variance are equal means Poisson. And mode is also lambda, it may be also unimode or bimode according to the lambda value. Next distribution is normal distribution. It is a continuous distribution. So PDF is denoted by f of x, 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. That is the PDF of normal distribution. Standard normal, that means z equal to x minus mu by sigma is known as standard normal variate. Then if you convert normal distribution into standard normal, the standard normal PDF is 1 by root 2 pi e power minus z square by 2. Now the differentiation between normal and standard normal formulas. For normal distribution, mean is mu and variance is sigma square. For standard normal, mean is 0 and variance is 1. Similarly, for normal, variance sigma square and SD is sigma. Okay. So SD is sigma. For standard normal, SD is 1. For standard normal distribution, variance and SD are equal. For which distribution variance and SD are equal means standard normal. Both are equal to 1. QD formula for normal is 2 by 3 sigma or 0.675 sigma. Okay. And QD formula for normal 2 by 3 sigma. Sigma becomes 1 means for standard normal QD is just 2 by 3. MD for normal is 4 by 5 sigma or 0.8 sigma. For standard normal, sigma becomes 1. That means MD is 4 by 5 or 0.8. Points of inflection for normal distribution, mu minus sigma, mu plus sigma. For standard normal, mu, mean is 0 and sigma is 1. So 0 minus 1 and plus 1 are points of inflection for standard normal. Okay. So dear students, please remember all these formulas. I wish all the best for your coming exams. Okay. Blast the exams with grand success. If you like my teaching and my topic, please subscribe and like the videos. It will encourage me and I will do more further videos for CA Foundation and also reasoning. Okay, thank you.